Leo solved a system of equations by graphing, and the graph is shown at right. Estimate the solution from the graph. So we know that the solution to a system of equations is where the lines intersect. So that's right here. So if I have to estimate it because it's not at an exact point. So I notice that we go over, let's see, I notice that our scale is 1, 2. So we're going over 1 and a little bit, not quite halfway. So I'm going to say maybe 1.3 for x. And we go up 1, 2, and then a little bit, maybe 2.2 for y. Write the equation for both lines in the system. So the first line, I'll call that line A, has a y-intercept of 5, and its slope, let's see, we go down 1, 2, 3, 4, and we went over 2. So its slope is the change in y over the change in x. The change in y was negative 4 over 2, which is negative 2, and the y-intercept was 6. So the equation is y equals negative 2x plus 6. The second line, so this is line A. Line B, we want the change in y over the change in x. So for line B, the change in y, let's see, I'll just put 2 points right here. The change in y is 2, and the change in x is 2. So it's 2 over 2, which is a slope of 1. And the y-intercept is 1. So the equation of that line would be y equals x plus 1. Solve the system algebraically using the equations you created in part B. How accurate was your estimate? So I know that both of these equal y. So I'm going to plug in x plus y for y into the other equation. So we get x plus 1 equals negative 2x plus 6. I'll add 2x to both sides. So that's 3x plus 1 equals 6 minus 1. 3x equals 5 divided by 3. And we get x equals 5 divided by 3, which is 1.7. Then we have to find y. So I'll plug it back in here. So we get y equals 1.7 plus 1. So we get that y equals 2.7. So the solution is 1.7 comma 2.7. So how accurate was your estimate? Pretty accurate, but the decimals are a little bit off. As treasurer of his school's FFA club, Kenny wants to buy gifts for all 18 members. He can buy t-shirts for $9 and sweatshirts for $15. The club only has $180 to spend. If Kenny wants to spend all the club's money, how much of each type of gift can he buy? Write a system of equations to represent the problem. So first we need to define our variables. So what are we trying to find out? How much of each type of gift can he buy? So the different types of gifts are sweatshirts and t-shirts. So I'm going to let T represent the number of t-shirts, and let W, because I don't like to use S's, represent the number of sweatshirts. So I know that he wants to buy a gift for all 18 members. So I know that everyone's either going to get a t-shirt or a sweatshirt. So T plus W equals 18. The number of t-shirts plus the number of sweatshirts has to equal 18 total, because there's one for each person. Then we know something about the money. T-shirts are $9 So $9 for each t-shirt plus $15 for each sweatshirt equals a total of $180. Now we want to solve this system of equations to figure out how many of each type of gift Kenny should buy. So I noticed that my T's and my W's are lined up. So I'm going to use the elimination method. The first thing that I'm going to do is multiply the top equation times -9 so that we get -9t here and positive 9t so that our t's will cancel out. So our first equation would be -9t minus 9w, and then equals -18 times 9 is 162. And we'll line that up with 9t plus 15w equals 180. We'll add these equations together. The 9t's will cancel out. -9 plus 15 is 6 sweatshirts, 6w, equals, let's see, 180 minus 162 would be 18. Divide by 6 on both sides, and we get that w equals 3. So we know that there's going to be 3 sweatshirts. Then we need to plug back into the original equation. T plus 3 equals 18. So T equals 15. So 3 sweatshirts and 15 t-shirts. Lenny and George do an experiment about how rapidly bunny populations can grow. Assuming the bunny populations in the table below grow exponentially, complete the following tables. Show your thinking or give a brief explanation of how you know what the missing entries are. So I remember that for an exponential table, it's going to multiply by the same amount each time. So I know I need to do 36 times 3, which is 108. And then 108 times 3 is 324. Here I know I'm going to have to times by the same number, but I don't know what that number is yet. So let's see, I'm going to try, I know that 6 times 4 gives me 24, but I need something in between. So I need a number smaller than 4. So maybe I'll try 3. 6 times 3 is 18. 18 times 3 is not 24. I'll try 2. 6 times 2 is 12. 12 times 2 is 24. Oh, here we go. 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. And 48 times 2 is 96. For the function f of x equals 6 over 2x minus 3, find the value of each expression below. F of 1 means that we're going to plug in 1 for x. So we get f of 1 equals 6 over 2 times 1 minus 3, which is 6 over 2 minus 3, which is 6 over -1, which is -6. F of 0 would be 6 over 0 minus 3, which is 6 over -3, which is -2. F of 3 would be 6 over 2 times 3 minus 3 equals 6 over 6 minus 3, 6 over 2, which is 3. F of 1.5 would be 6 over 2 times 1.5 minus 3, which is 6 over 3 minus 3, 6 over 0. Uh-oh. 6 divided by 0, you can't divide a number by 0, so this is undefined. There is no solution here. That number doesn't exist. What value of x would make f of x equal 4? So we want f of x to be 4, and we want to know what x is. So I'll make the equation. 4 equals 6 over 2x minus 3. So right now we're dividing by 2x minus 3. So I'm going to multiply both equations times 2x minus 3. That'll cancel out the division. So I'm left with 4 times 2x minus 3 equals 6. Now I'll distribute the 4, and we get 8x minus 12 equals 6. Add 12 to both sides. 8x equals 18. Divide by 8, and we get that x equals 18 over 8, which simplifies. I'll divide both by 2 to 9 over 4. Write the equation of the functions that would do the following transformations. Horizontally shifts the parabola y equals x squared to the left by 3. So remember the main graph I have the main equation for a parabola is y equals a times x minus h squared plus k. H gives me the horizontal shift. So I want the function f of x equals, I want to go to the left. So minus a number takes me to the right, plus 3 squared would shift me to the left. To reflect the function y equals the absolute value of x over the x-axis. So reflect means to flip it. So to flip the function upside down, we have to put a negative in front of it. And here we want to vertically shift the exponential function down 5. So k is our vertical shift. So if we want to move it down 5, we'll have y equals 2x minus 5. We're making it go down 5.